Our next topic is going to be taking a look at how we can modify, create, delete both files and folders as the Linux command line interface. So let's start with the touch command. The touch command is interesting. It's meant to, let me take an example here. So I do a ls-l in my home folder, okay. I have this example.desktop file that I haven't, literally, no pun intended, but I haven't touched it, meaning modified it in quite a while, okay. So the purpose of the touch command is to say, I want to make the following file. So I'm going to specify a file name here, so I can specify an absolute path to that file name or a relative path to that file name. You know how it works now. And I want you to actually make it so that it looks like I just modified that file. Okay. So there are more options to touch. You can explore them on your own. I mean, it's trivial stuff. You can say, for example, I want to touch that file so that its last modification timestamp is actually matching the last modification timestamp of that other file. Things of that nature. Okay, but the whole idea of touch is, as the name implies, and you probably see how it makes sense now, I want to make it look like I did something on that file. I want to touch that file right now. So if I do ls-l, you see that this was my my date here of last modification, okay? And now I issued a touch command. So this is a date of last modification, and it has been based on the current date, okay? So a very basic command, and really it doesn't sound like it would be really useful here. But there is a side effect to that command. I can say touch and something.data, okay, a file name that doesn't exist currently. So something.data is a relative path to the current working directory, and the name of the file is something.data. So I don't have that right now. I issue the touch command, now I do a ls, and lo and behold, I have a something.data file that has been created. So without introducing commands that we're going to talk about only later, okay, if I try to take a closer look at something.data, I can see here that the size of the file is 0 bytes. So it's an empty file, okay. By default, it would be a text file, I guess, but since it's empty, it doesn't even matter what kind of file it could be, okay. There's no structure or format to the file. It's just an empty file with 0 bytes of data in it that has the name as specified as parameter to the touch command. And if we look at the last modification time, well, of course, as a side effect, it's set to whatever is the current time and date, okay, when I apply the touch command, obviously. So, so this is an interesting little command, and everybody introduces it. I mean, everybody, I guess, almost everybody introduces it when we talk about creating file. This is the easiest thing you can do: create an empty file. Okay. Other than that, you could open your text editor on your favorite Linux distribution, obviously, and do the same thing. But this is going to be convenient also for us to create some bogus files like that have no data in them, and learn to erase them, and learn to move them, copy them, etc. as we talk more about file system operation from the command line interface. So that was the first step, the touch command. So now let's say that I want to get rid of that file. The command to do so is called rm, stands for remove. So I can do rm and specify again a full path, an absolute path, or a relative path to some file, and it's going to remove it for me. So when I do again a ls, it's gone. Okay, what's next? Well, we talked about creating empty files, destroying empty files right now. Very interesting. Let's talk about folders a little bit. So we have a different command in the bash shell to create folder, mkdir, make directory. Okay. So if I, again, every one of those commands that operate on the file navigation theme, you know, in the CLI, they accept relative and absolute path. Okay, so even though I illustrate them most of the time by using a relative path that's relative to my current working directory, you could say things like /untux/ for example, a folder edu, where I'm going to store everything about my course. Okay, so if I type something like that, mkdir/om/tux/edu. Now I look at what's inside /om/tux, and I should find somewhere, there it is, the edu folder I just created. Okay, and now I can go into that edu folder, no problem, and I find, of course, nothing in there. So the same way I can use an absolute path, I can also use a relative path. I can say, okay, let's create a COP 3353 subfolder here. I can say, let's create a COP 2512 folder. So I'm kind of like showcasing all of the different relative and absolute path names that we have been already discussing about. And then here we go, I have my folders. I could also ask to create a folder that says, for example, mkdir, what should I do? COP 2513 module 01. All right, so I'm trying to do two things at the same time here. Really, I'm trying to, like, for example, if I was using COP 2512 here that already exists, okay, that would not be a problem. It's just me specifying, you know, pretty much a relative path name here to the M01 folder that is a subfolder inside of COP 2512. So if I do ls, okay, I don't see anything new, but if I do ls 2512, here we go, my folder has been created. But what I was originally trying to do is something like this, which means I am trying to actually specify that I want to create a folder M01 inside a folder that doesn't exist right now inside my current working directory. Okay, so if I try this, cannot create directory, blah blah blah, COP 2513 M01, no such file of directory. What it really means is that this part was a problem. Okay, this part here was a problem because it doesn't exist. So if you tell me to create something inside something else that doesn't exist, then the whole thing fails. All right. So as proof, there we go, nothing got created. But there is an option, because this is a case that you're going to encounter quite often, especially when you're scripting. So there is an option of mkdir that is worth mentioning. It's a -p option, because that -p option is going to first prevent an error if one of the folder that you mentioned in your path name does not exist, besides the last one that you're trying to create, which that one obviously doesn't exist, okay? But if any other folder in the path name is missing, it's not going to trigger an action. And second side effect, which is a very interesting one, if anything needs to be created on the fly, it's going to be created on the fly. So here ls COP 2513 contains M01. So it has been created on the fly, and then the mkdir command created the M01 subfolder inside of COP 2513. So you are going to hear me mention some of the option of commands, okay? We are going to be very soon going through a video where I'm going to give you some basics on how to obtain the manual information on all the commands and get help pretty much when you want to know everything that's available, for example, for the mkdir command. We already mentioned the option --help that is available in many commands, if not all commands on a Linux system. So that allows you to find quickly, you know, options like -p, okay, that are going to, in one sentence, summarize pretty much what they're doing, and that might be just what you need. But we're going to go more into depth in that topic of how do I get documentation on all of the shell commands very soon, okay? So bear with me for now. But the idea is that when I'm showing things like this, I'm going to illustrate the most commonly used commands, but I really recommend, and it's a very strong recommendation, that you take some time as soon as we learn how to access the manual of every command, that you take some time taking a quick look at all the options that are available. I don't ask you to memorize them. I just ask you to be aware that way of what this tool, for example, mkdir, can do. So you hear something about, you see something here about, well, we can set a permission mask. So we haven't talked yet about permission. We'll talk about it in the module dedicated to the file system, okay? But that's useful information for you to have. There is a way for me to create a folder and specify permission. There is a way for me to create a folder, and if some directories do not exist on the path name, you know, get that also created. There's a way for me to display more information as I create those folders, okay? So it's not about memorizing all those commands, it's about really getting an idea of what mkdir can do for you. And later on, if you remember those little tidbits of information, later on when you have a task to accomplish, these are going to be already in your mind, and you're going to say, well, I think that mkdir can do something about creating missing folder. Let me check the documentation. And then you'll go into detail, you'll figure out not only if that's actually if you remember correctly, if that's actually the case that mkdir can do something like that, and then you're going to find the option name, you're going to look into its syntax. So all of that you don't have to memorize, but you have to at least memorize to a certain level, what each command can do for you, or have a vague idea so that you can find further information in the manual when necessary. So enough about that. Let's go back to the main flow of this video, and let's go back to our operations on different folders. So I'm going to cheat a little bit here. I'm going to use a command tree. The command tree not only is not a built-in of the bash shell, unlike other commands that we have been using so far, but it's also something that I had to install on top of my Ubuntu system. So if you just try it right now as you watch this video, you're not going to be able to execute tree on your system, but very soon we are going to cover the installation of software package, and you'll learn how to install additional commands, additional tools on your Ubuntu system. Okay, so for now, let's just use it as an illustration. The reason I like tree is that if you specify tree and with that parameter, it just assumes your current working directory, and it displays a nice representation of everything that's in your path. Okay, so if I say tree/home/tux/edu, which is what I just did with that parameter, pretty much, I see everything that is under /home/tux/edu in a nice semi-graphical representation. And of course, if I have files, so if I do touch, and I'm going to use a relative file name, okay, cop3353 readme.md. Okay, so I created an empty file. If I do this, now I can see that most of those folders are empty, and this folder has actually a file in it. Okay, and if I don't want to see the file names, there's a nice little option here that says D for directory only, and there we go. So when you have a lot of files, like for example, if I do tree/etc, this is going to be insane. Okay, I'm scrolling here with the mouse. There are a lot of files in the folder, so it's a quite long output. So you can simplify this output at any time by saying, okay, I just want to have the directory structure. Okay, so I do /d etc. I don't want all the detail, I just want the directory structure, and it's a little bit more manageable. Even for /etc, obviously, is a huge hierarchy in its own. Okay, and you can see that when you don't have permission, because I'm logged in as a regular user right now, when I don't have permission to access some folder, tree is going to tell me the folder exists, but it's going to tell me I cannot get into that. So we'll come back on file permission and folder permission very soon. Okay, just illustrating here the structure of the little hierarchy that we have been creating with all those mkdir and touch commands. So now we're going to use that to play with removing folders. So removing folders, there are two ways to do this. The first one is rmdir. So it's easy, okay? Mkdir make folder, make directory, rmdir remove directory. Easy to remember. If I say rmdir cop2513, so I use a relative path here, 2513 and 01. Okay, so I'm trying to get rid of that folder here. All right, no problem. And if I do a tree, it's gone. Okay, so let's say now that I want to rmdir cop3353. So the difference is that M01 up here had nothing in it. So rmdir was more than happy to get rid of that empty folder for me. Now cop3353 has actually some files or subfolders in it. Okay, in this case, file. And when I try to rmdir, it tells me, watch out, you're about to destroy potentially some data. So rmdir is okay with deleting a folder, that has nothing in it. No problem. But as soon as it has something in it, it's going to raise a warning. So there is another way to remove folders. And now we're going to talk about the rm command. So the rm command can be used to remove files, to remove folders, and it has nice options that allow you to destroy everything when you're absolutely, and I don't know how to formulate this, you have to be absolutely 100% sure of what you're doing when you use some of those options, okay? So let me show you exactly what I mean. I'm going back to my home directory. So there we go, pwd, I'm in /home tux. So I have inside of this, subfolder edu with a bunch of stuff in it. If I do rm edu, it's going to tell me you're trying to remove a directory. RM is meant by default to remove just files. So you need to confirm to me that you know what you're doing. And this is where the -r option comes into play. So R stands for recursive. Recursive means I want you to remove edu, and if edu contains anything, whether it's a folder or file, I want you to remove also that file or folder. If it's a subfolder we're talking about, well, look into that subfolder, and if it contains a file or another folder, remove also all of those files and then remove all of those folders. So call yourself recursively on each of those folders and keep removing everything like that, until you are done. So if I do rm-r edu, that sounds like a quick and painless command, but now everything is gone. Okay, everything that was in edu is gone. And if you rm things on a Linux system, it's not like erasing things on a desktop system. Most of the time, if you erase something on a desktop system, the GUI features something called the trash, and really what happens is that the information is not removed from your disk, it's just moved out of the way into the trash. And once in a while you can go in the trash and purge completely the trash, get rid of the data you haven't touched in years maybe, or you can go to the trash and say right click on a file and say restore, and bada boom, your file is back, like if you never erased it. So this is really convenient. When you are using the command line, there is no trash. Okay, so that means that if you rm-r a whole hierarchy of folders that is like 2 GB of data on your disk, it's gone. Okay, so what do I mean by it's gone? This is not an operating system class, so we're not going to talk about the structure of how the file system is constructed on disk actually, but I just want to give you a kind of a general idea of what's going on here. Pretty much all the blocks of data that are constituting your files and folder structure, etc., are unlinked. So in a way, you do not have access to the first block of data. So even though the blocks of data are still on the file system, they are marked as unused. And that is enough to actually prevent bash and any program you write, to just open a file with the file name and its path, and access the data. So in other terms, edu is still somewhere on my hard drive. The data that was in edu and all of its subfolder and all of its files, etc., is still on my hard drive, but it has been pretty much disconnected from the flow of the regular file system so that we cannot access it easily. And the keyword, the operational keyword here is easily. And we're going to talk a little bit more about that in the file system module. But easily means that if you are actually doing forensics on a system and you are trying to do a low-level scan of the hard drive and see the information that was there, if we add any information inside readme.md, it would still be there. We could, to a certain extent, recover, but this recovery is not easy. Okay, you have to use specialized tools. So for all intent and purpose, in a course like this one, where we are just getting at the initial level of using a Linux system, once you RM something, it is good and gone. Okay, but for security purposes, doing RM to get rid of data on your hard drive is not enough. You would have to use other tools that we're going to discuss maybe later, okay, that are specialized tools that allow you to scrub actually the data from your hard drive and not simply, make it more difficult to access. All right, so that's one of the dangerous options, as you can guess, for RM. An even more dangerous option is that sometimes when you try to RM things that do not belong to you as a user, you're going to get warnings and errors. RM is not going to want to continue. If you specify the additional option F for that stands for force, then it's even worse, because you are saying every time you would ask me for confirmation to erase something, just go ahead and assume that yes, I give you confirmation. So rm.rf in this introductory Linux course that we have here is probably one of the very few commands we're going to talk about that has real potential to break your system, okay? If you are trying to do something like, for example, rm-rf/home/tux/edu, okay? So this is erasing the edu sub-hierarchy, you know, inside your home folder. But let's say that you do a simple, very stupid typo, like you put a space here. So it's going to tell you at some point, I cannot find home tux edu starting from the current working directory, which is your home directory, okay? Because you can specify with the rm command or even the mkdir command, you can specify several arguments, okay? Like I want to rm des subfolder and des subfolder. It just so happened that here what you meant to do is to specify only one argument, and you hit the space bar by accident, and now suddenly you're specifying two arguments, one that's not going to be found given the current working directory, so no biggie, and one that is just the root of your file system. So this is where it's annoyingly dangerous, because what you're in essence trying to do here is wipe out your entire file system. So be really careful when you do rm-rf, okay? It's really not a good idea to type this really fast and just close your eyes and hope everything is working fine. In most cases, you should be able to use rmdir to erase folder only when they have been properly cleaned up and erased. And it's longer to erase every file in a subfolder by hand, okay, obviously, but it's also a lot safer. So like your home directory, you have a lot of information in it. Make sure that you do not take a quicker than deserved shortcut with rm-rf and lose everything that you have been working on this semester, for example. Okay, so be careful about that one.